So in this video we will study about arithmetic progression. Arithmetic progressions can be explained as a series of numbers are said to be in arithmetic progression if difference of any two consecutive numbers is same. It can be explained better. If I start with a term called A, this is my first term, then I go on adding a common difference D, I get A plus D. Further, if I add D, I get A plus 2D and so on. In such a case, the nth term in such a series will be Tn equal to A plus n minus 1 into D. Fine. So this is how arithmetic series is obtained. We can construct a series which is an arithmetic progression starting with a number and taking a common difference. This common difference is called D. Fine. Now example can be taken. A numerical example, we start with 2 where A is equal to 2. A is the first term, so which is 2. And the common difference I take as 3, therefore D equal to 3. Now let us build the series 2, 5, 8, 11 and so on. Okay. Now in this series if I want 20th term, okay, then in this particular formula Tn equal to A plus n minus 1 into D, in that if I substitute n is equal to 20, then I get T20 which is 20th term can be written as A which is 2 plus n minus 1 which is 20 minus 1 times 3. Fine. So it is 19 into 357 plus 259. So 20th term is 59. So we have obtained nth term given initial values A and D. Fine. So this is how we can construct any arithmetic series. Fine. How about finding sum of n terms? Yes, this can be achieved in two methods. The first one is explained here. Yeah, it is denoted by Sn. Sn is sum to n terms, which can be taken as n by 2 times 2a plus n minus 1 into D. Okay, assuming you are given only the first term A and the number of terms n and L the last term. If A, n and L are provided, still you can find using the second formula Sn is equal to n by 2 of A plus L, that is first term plus last term. If you add them and multiply whole thing with n by 2, yeah, total number of terms, half of them, if you multiply you will get that sum to n terms. So this is the second method. Fine. With this we have identified what is nth term, what is sum to n terms in two different ways, and how a series is generally explained as A plus D, A plus 2D. With a numerical example also we have tried to understand it. Now coming to the next part of it, here we can have a finite series and infinite series. A series is said to be finite series if the number of terms are finite. We can take the multiples of 3, we can take positive multiples of 3 which lie between 0 and 100. So 0 greater than 0 and less than 100, if this condition is given, so definitely I am going to have my first term as 3, next term as 6 and then 9 and so on up to the last number that can be divisible by 3 below 100 is 99. So, up to 99 is the total series. So, how many terms are there in this particular series? For that, we can easily understand that 99 is the last term. So, I will call Tn equal to 99, and Tn is also given by the formula a plus n minus 1 into d. Here a is 3, n I do not know what is n minus 1 into d, the difference of course is 3. So, 3 plus n minus 1 into 3 equal to 99. This implies, so 3 plus 3n minus 3, which is equal to 3n, which can be taken as 99, thereby giving n is equal to 33. That means there are totally 33 terms in the series, right. This is what is called finite series. Okay, that's good. Now, what is an infinite series? Infinite series, so this can be explained as with an example. If you take it, all even numbers, yeah, all even numbers starting with 0, starting with 0. What does it mean? Here a equal to 0, and because it is even numbers, the difference, common difference equal to 2, and therefore the numbers are 0, 2, 4, 6, 8. Where it is going to end? It will not end. It goes to infinite number of terms. Infinite number. Infinite number of terms. So, this is called infinite series. So, you have understood the difference between finite series and infinite series. Yes. So, having completed this, okay, we have obtained a series, a finite series in the above example 3, 6, 9 up to 99. Let us take that to work on some 10 terms. Okay. Now, the series is 3, 6, 9 and so on up to 99, and here I want to have the sum of all this. So, Sn, here n is 33, therefore, S33 equal to n by 2, that is 33 by 2 of compressed last term, because last term is provided to us. The second method we have to use here. So, 3 plus 99, 3 plus 99, which is 102. 102 divided by 2 is 51. So, 33 into 51, you are going to get 1683. On simplification, you get 1683. Okay, coming to the second method also, actually this is the second formula what you have used. If even using first formula also you can solve it, let us also check that. Okay, what is first formula? N by 2, that is 33 by 2 into 2a, that is 2 into 3, 6 plus n minus 1, that is 32 into d. So, n minus 1 is by 3, 32 into 3 is 96. So, 96, 6 plus 96, which is again 102 by 2, which is 51, again 33 into 51 is 1683. Yes. So, like this, both the methods will provide the same result. So, only thing is, what is the given data? As per the given data, we can choose a formula accordingly. Okay. Now, we have understood that given a and d, we can easily find nth term and also some 10 terms. So, this is what we have already identified. But there are going to be quite different patterns of questioning in this particular chapter. So, in the examination they will try to twist the question in different patterns and present it. So there are a number of types of questioning methods are there. So we will consider some of them here. Okay. So first step already we have seen type 1. Type 1 is given A and B. Yeah. Given A and D, we can find Tn. They may also ask you Sn. So Tn and or Sn. So they may ask you either find Tn or Sn or both. So these questions can come. So just now I have seen a question how we found the summation given A and D and A and L. Okay. So this is one type, already we have seen it. Okay. What is type 2? Type 2 is going to be given A, you will be given A and nth term to find, then you will be asked to find D common difference and or Sn, sum to n terms. So common difference they may ask you, or sum to n terms also may be asked in this particular type. Okay. So from textbook we can take up some of these exercise questions. So let us take up from first exercise. So he can as well ask you, he will give a series, he will ask you to confirm whether they are in really AP or not. Okay. For example, I will give you one question, whether in AP or not. Okay, we will find out. Right? Yes, the question asked is, let us say root 2, root 8, root 18, root 32, etc. Right? It is going on increasing, but we don't know what are these. Are they really in AP or not? So let us check. Root 2, find root 2 has a fixed a rational number. We have to take it as it is. 8 can be taken as 2 root 2, and root 18 can be taken as 9 into 2. 9 can be taken out to make it 3 root 2, and 16 can be taken out to make it 4 root 2, and so on. So have you seen it? 1 root 2, 2 root 2, 3 root 2, 4 root 2. Each time we are adding a root 2 terms to this. So that is, the series can be written as root 2, root 2 plus root 2, root 2 plus 2 into root 2. Okay. Yeah, are able to see this? A plus D and A plus 2D. So here A equal to root 2, also D equal to root 2, and the series expands like root 2 to root 2, 3 to 4 root 2, and nth term of this particular series will be n root 2. Yes, n root 2 will be nth term. That's all. So this is definitely in AP. Yes, our answer is yes.